Hello, everybody. Good evening. Welcome to the third session of the Joy of Coding at Portland State University. Let's see here. So we're starting at our new time for Monday, 6 p.m. It looks like the classroom is available, so that's good. I still don't know whether or not we'll be able to start on at 6 p.m. on Wednesday. I'll let you know tomorrow if I hear back from the person who's teaching that course to see if that is an option that's available to us. It might not be. They've got the room scheduled until 6:30, so if they, if they need it, then they get it. Right, it's there. So we'll try our best. Another thing about the class schedule I realized is that when I laid out the course, I had forgotten that Monday, January 20th is a holiday. So I need to move things around a little bit. Um, I was I was really happy with the flow of these things, and so then I'll take a look at this tonight and pose some questions there. Uh, I had wanted all of the pairing and mobbing to be on Wednesdays, but I might need to move this first pair programming experience to Monday the 27th. Anyway, I'll put all this out on Slack. Let me know if that's a problem for you. I don't know if anybody sort of adjusted their Wednesday nights around that. If you're arranged for childcare or worked out something with your spouse or whatever to make sure that that you could be here on campus for that Wednesday. If Monday the 27th is a problem, then let me know. We'll figure something out. But anyway, so I'll change some things around and I will let you know what that is. I've got some homework tonight to do, I guess, because I didn't pay attention to the calendar. But anyway, enough about me. How's everything with you going? So last week we talked about the koans and got to see them, got to work with them. I hope you've had a chance to pursue them, to work on them. I saw some good chatter on Slack about them. How are you finding them? What have your experiences been like so far? I'm seeing some nods, some thumbs up. Okay, good. Meaning I hope things make sense. Um, Anything surprising? Any learnings? Any part of the language where you're like, oh, I didn't think it worked that way? Nothing pretty straightforward. That's okay. Nothing wrong with that. Okay. Um, what else? This is Prime Minister's questions. You can ask me anything on your mind, anything that you're curious about as we get started. Yeah. Yeah. Oh yeah, yeah, nice. About mocks. Yeah. The simple anonymous mock. Gotcha. Yep. Yeah. And this is in the advanced section because it is one of the more advanced concepts. And we'll see all this stuff again. I don't know, in several weeks when we learn about Mockito and mocking with that. But the whole idea here is that what? Okay. So uh, the class under test, right? Class under test has two constructors. One takes zero arguments, and the other one takes an argument of type collaborator. So this is meant to demonstrate what's called the dependency injection principle. The whole idea is that you've got two objects that rely on each other. You have one object that uses another. In this case, the class under test uses some instance of collaborator. And in sort of the prototypical example of this is you have a class that calls a database or makes a network connection out to a REST API or reads the file system or whatever. If you want to write a unit test, and we'll learn about this tonight, unit tests, and hence this koan, unit tests should be fast, should be simple, and shouldn't rely on something like a database server running or a REST API being available to call. And so a technique for being able to write code that is testable, even though it depends on something which is really not that testable, like a database, is to use this dependency injection pattern, meaning that when you create your class under test, you provide it with the object that is that you provide it with the thing it depends on, as opposed to having it create the thing it depends on itself. So yeah, what I'm guessing that you did is that you, so let's see here. Uh, so like, how does it invoke? Well, okay, yeah, so then you can do something like make a new collaborator. Oops. Collaborator there, and then you can, oops, you can hit the right key. You can create a local variable for it and have this be a new collaborator. And then, do business stuff. Here, you probably just want it to do nothing, right? Because like by default, the real thing is this explosive collaborator that just calls fail. So what you would do in like a unit test is that you would provide it with a mock collaborator that basically does nothing or does whatever you want it to. So for instance, let's say we'll see this in the REST API, right? You have a client to the REST API that takes an object that invokes the REST API. And what we'll do is that we will use a mock REST API that always returns whatever information that you expect. So like, great, you send a query like, hey, tell me all of the flights in an airline, right? And just have it return it, which is fine for your tests. What you're testing is not the service itself, but the thing that interacts with the service. Anyway, that's just my brief sort of explanation of that. I don't know if that makes sense.
Yeah, so you're just
Exactly. So for the purposes of this test, it's like I don't care. The collaborator, I want it to be, I want it to behave exactly how I want it for this test. Not the real world one. The real world one, sure, it uses this explosive collaborator. But here, just for my test, in this case, the koan, I just want to have a happy collaborator that behaves the way I want.
and then you can't make it any different for collaborators.
Correct. Collaborator, I believe, is an interface. Yes, collaborator is an interface. Interfaces specify behavior, not state. So you can't. So it's like an abstract class. You can't instantiate a collaborator directly. Instead, you need to instantiate some class that implements collaborator. And the code that's written here creates an anonymous inner class, which is some instance of collaborator. Who cares what his name is? Because you're not. You don't really need to give it a name. All you say is this particular collaborator that I created has an implementation of business stuff, which is, do nothing so the test pass. So the koan passes. Yep. Pretty advanced stuff. Agreed. But this is where I hope you get to the end of the koans in the next couple of weeks, so that you can at least get a taste for this, and then when you see it later in the course, you'll be a little more familiar. Good question. Next, I'm just going to undo this change here in IntelliJ. Anything else for the start of class? Anything else that's on your mind? Any questions, ideas, comments, feedback? Go and chat. Okay. Well, cool then. Let's get started. So tonight we are learning all about test-driven development. And so this is a key concept in the course. This is a way of approaching your code so that you can express upfront what you want your code to do and validate that your code does what that you want to do before you even write the code. And there are lots of advantages to this, even though it can seem really counterintuitive at first and can be hard to do when you begin doing it. But what I've found is that test-driven development really helps me focus, and it lets me know when I'm done, and it lets me know if I've broken anything. These are really powerful concepts. They help you go fast with confidence. And what we'll be doing tonight is we'll implement that. We'll begin implementing that student program, which is which I think we saw mentioned in the README for the Getting Started repository. But first, now before I go into this handout, let's watch a video. I'm going to share my screen so that everybody at home can hear the audio. Let's see here. I'm going to share this. I'm going to share sound and optimize for video sharing. Nice. Okay, so this is going to start automatically. No, good. This is okay. So this is a video by Bob Martin, known as Uncle Bob Martin, all about test-driven development, and it really shows the thought process that goes behind it because there is a practice to test-driven development. There's there's a technique that has evolved over the years that really makes it effective to be able to think about what it is that you're trying to express, implement that, express that as build a test that validates that expression, see it fail, and then make it pass and look for opportunities for improvement. And so this is a 5-minute video. This is part of his Clean Code series. He made it available for everybody to see. The audio should start shortly. Anyone who's remote, let me know if you cannot hear the audio. Audio hasn't started yet. Once you see him talking, it'll start.
Oh, it's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right, what test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0. I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes. And now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Okay, happy coding. Indeed. So, what did you observe about that video? You were watching Uncle Bob code. He was running a test. He was making it pass. He had a silly hat on. What did you see? What did it mean to you? Okay. So you said it was nice to write the test. Why did it seem nicer to you to have the test first before you write the code under test? Okay, right. So yeah, it seemed like you weren't going to miss any details because you were, you had a test to make sure the details were implemented correctly. Okay, cool. Yeah. Oh yeah, I like that. Right? Yeah, he was very focused on the problem, on the domain that he was working in, which is bowling, right? And so yeah, his mindset was in really the requirements of the code, not so much the implementation. The implementation sort of flowed from it. Yeah.
It's kind of like you start by hard coding the desired result and develops backwards.
Oh yeah, I like the way you put that. So like he starts with like the future that you want to see. Like here's the result that I want, and he sort of backs into it by writing the code. What do you think about that?
That kind of stressed me out because during this thing, it was like a little, it seems like
Yes.
it was starting with such a granular level, like when we go through the larger context of this, like you can't just have it with zero all the time.
Oh, yeah, okay. I like what you're calling out there, right? Is that's some of the discomfort about test-driven development, where it's like, you're thinking about the domain, and it's like, oh my gosh, but I've got all these other things to think about. I think it's one of the key disciplines you need to have is realize that that stuff will come later. I'm confident that you'll get there, and focus on like what are the small steps to get there. I know one of the mistakes that I've made a lot in my career developing code is I try to jump to the end. I try to like get everything there, and I end up with like a mess, and I get lost along the way. What I've found is that with test-driven development, because instead of taking giant leaps or whatever, you just sort of like take these small steps, and all of a sudden, poof, you get there. Or you realize you're at the end, and there's a whole bunch of stuff you didn't need to do. The stuff that you thought at the beginning, it's like, oh, I'm going to need this and this and this. I should have this class. It's like, oh, you know what? I came up with a solution. It's good enough. It works. I have tests to prove it, and I didn't need to do a bunch of stuff. But yeah, it's probably very different from sort of what we're used to. See here, a question came in. Is it okay to assume that TDD is essentially setting up all the unit tests that are required by the specifications before writing the code? I would say that's almost, it's almost the right assumption. You don't write all of the unit tests. You see what he did there? It's like, is it red-green refactor? So like the first thing you do is like, what's like the most, what's the first step? What's the simplest thing for it to do? Okay, you write that, and then it should fail initially because, well, it's not implemented, right? I think the first test he wrote with like just creating a new game, man, that's not very lame. But that second one, where well, actually, it was really the third one, I guess, where he actually has that assertion in there when he performs a little operation on his game and then asks for the score. It failed the first time, and it's really important that you see your test fail the first time. That's how you know it's the right test. I've made that mistake several times, where it's like I write a test and I think it's all right, and then I didn't bother running it to see it fail. I'm like, I don't know, it's definitely going to fail. And then like I implement it, and I think and then it passes again, great. And then I realize that, oh wait, I wasn't comparing the right thing, or oh, okay, there was some subtlety there. So it's really important to see it fail like he did, and that's why he had score return -1 initially, and then he changed it to 0. So, but then he went and got that much, and then he put on a little refactoring, the blue hat. Do you know what refactoring is? Have you heard that term before? How do you define refactoring? Yeah.
When you find something that's a duplicate and then you consolidate, consolidate that so that share.
Right, it's a good example of refactoring. You got duplicate code and you put it in one place. So, a code block is repeated twice, put that into a method and have those two places called a method instead. More generally, refactoring is all about a change to the code that doesn't change the behavior, the external behavior, but in turn it changes it improves the internal quality of the code by removing duplication or improving names, or by making code more easily reusable by factoring it into class hierarchies, things like that. Now, we'll be learning a lot about refactoring later, but for right now, I think what you need to know is that as part of test-driven development, you do the red, which is you write a test that fails. You make the test pass by implementing the logic that's under test. And then you look for refactoring opportunities. Look for like, hey, as this code is evolving, as I'm adding more things to it, can I make it better? Nice. Any other observations about the video, about what Uncle Bob was showing us? Yeah.
Is there a way to evaluate test coverage?
Oh, is there a way to evaluate test coverage? Yes, there is. We'll be talking about that, whenever we talk about this, how to test your projects. You can go read ahead on it, but yes, exactly. As a matter of fact, something that's required for this course. Spoiler alert, I require that there's at least 75% line coverage or instruction coverage in your code. So yeah, you do have to write tests for the projects. Awesome. Okay. I will, let's see here, I'm going to go back to sharing the screen the normal way. This works a little better, I found. Some no sound, no video. Okay. Now there's a handout that we're going to use. I'm going to post it in, I'll post it in the Slack, I guess. There's Slack. There's the handout. For tonight. It's not really a handout, is it? It's a collaborative document. Anyway, I think that's it. And actually, let me check to make sure I gave everybody permission to. Yep, anyone with a link can edit it. So good, people are showing up. Good, awesome. Okay. So we just saw that video about test-driven development. There are a couple other concepts that I want to talk about before we get into the activity tonight. So what we're going to do is we're going to implement a simple Java class that's a lot like a project, so it gives you an opportunity to understand those. But there's some things that I want to talk about in terms of how you design and express test scenarios. So there is a popular form of expressing behavioral scenarios called given when then. That's what it is. So for this scenario, you talk about there's a given part, which means this is like the initial context. It's like, hey, starting from this point, so that's the given. It's like that's what you do to set up the scenario. There's also the when part of the scenario, which is the interesting thing. So that is the behavior that you're testing. That is the thing that performs the scenario. And then the scenario has the then part, which is all about the expected outcome. So you're basically saying, hey, listen, under these conditions, when I do this thing, I expect this other thing to happen. That's what the then is all about. And so then by using these three clauses, these three parts, you can describe the intended behavior of your program, of your software. There are tools and frameworks where you can write these things in pretty plain English and then convert them into code and stuff like that. We're not going to be learning about them in this course. Instead, what we're going to use is this given when then structure to explore the student class. I'd like to give credit where credit is due. Dan Terhorst North developed given when then, or is credited anyway for coming up with it as part of behavior-driven development. And if you want to learn more about it, Martin Fowler, who's a luminary within software development, he's got a good article on it also. So what we're going to do at the beginning of class tonight is brainstorm some scenarios for the student program. So let's take a walk through this. So this is a project that many years ago was like the first project in the class. Then I realized that it really didn't give you much more than what you did in project 1, and so then I just used it as an example instead. But the whole idea, but it's kind of like your project 1, so I think it'll introduce some of the concepts to you. So what we'll be doing tonight is collaboratively writing a student class, which subclass is human, which is one of the classes that I wrote. It's mentioned in the object-oriented programming lecture. And what we're going to do here is learn about object-oriented programming, like inheritance and virtual methods, but also learn how to read program arguments from the command line, and then work with somebody else's code. So the way you get started with this is by creating a new project in your Git repository. So I'm going to log into, let's see here, I think I did that as me. I'm going to log into the PSU machines because you may recall you run the create scripts from the PSU machines. Here I am in my Git checkout, and I think I want to pull the latest changes if there are any. I don't remember if there are. Oops, I typed that correctly now. Oh, there were a couple of things. It's a couple of koans. Well, that's good. Now I'm going to run the create student script, create student project script. This will go off and add a new project to my repository. It'll use what's called a Maven archetype to do that. This is just like what we did with the koans project, but now we'll be creating the code for that student project instead. When I run git status, we'll see that it modified my pom.xml because it added a new project to this repository, and then it adds some student files. So I'm going to add those to Git. And then how am I doing on status? I need to add the pom also. As you can see, in addition to some Maven stuff and a pom.xml for the student project itself, it's got a couple of classes like student and student test, also the student integration test. This is what we'll be working with tonight. So, yep, everything's there, and now I'll just add the added the student project. By the way, you're free to do this, but there's not really any reason, only if you want some practice coding and stuff. And if you're going to practice coding, do the koans or project 1. Nice. I just pushed a bunch of stuff up to GitHub. Okay, so I created that. Here again, just like creating the koans project, you run a script and then you add the code to GitHub. So I'm done on the PSU machine because now I'm going to do the rest of my work locally. So here in the PDF, I have the code that is generated. I think I want to look at this in IntelliJ instead, just so we can walk through it a little bit easier. So here I've got, this is on my local machine, I've got my checkout of my repository, and if I actually, under here, under Git, if I say update project, what this will do is it'll reach out to GitHub and get the latest changes from GitHub, and so then that should get the, yep, it said that there were 10 files, updated in 1 commit. And let's see here. It is, oh yeah, it's syncing the project, meaning that it's, because there was a new, because the student project was added, it now recognizes it as, as a module within this bigger project. It is giving me a warning about this parent.relative path. This is just a warning, nothing to be concerned about, although I believe there are some descriptions. There is a paragraph or two in the readme.md that explains what to do about this if you want to get rid of that. Warning. Okay. Now, here in the student project, in the source main, there is a student class. And so let's walk through what the student class is all about. So it's a class that extends human, which gives it some inherited methods. A student constructor, it takes a couple of parameters. There's the name parameter. There's the classes parameter. Okay, so a student takes a number of classes. A student has a GPA, and a student has a gender, which can be specified as male, female, or other, all case insensitive. Good to know. The constructor, let's see here, it calls the it calls the superclasses the inherited constructor, which is inherited from human, and I can navigate into this by saying go to declarations or usages. It finds the code, and I can download the sources so I can see the actual code here. That's cool. So there is the human. Let's see here. A human extends mammal. Humans say hello. English-speaking humans do anyway. And so every human has a name. Let's see here. This name, I'm going to navigate into this. I guess all animals have a name. And all animals say something. And they've got a toString that says, okay, this is kind of cool. This is all code that's from the object-oriented programming lecture. I'm just kind of getting familiar with it. That's kind of cool. Okay, so that's what a human's all about. And so a student is a human, so a student inherits all that stuff. Okay, good to know. Let's see here. A student, a student overrides the says method. And according to this comment right here, all students should say this class is too much work. Okay, that makes sense. It looks like it's not implemented yet, so that's something that I'll have to work with. Same thing with toString. The toString method returns a string that describes the student, and I believe that in the assignment we have more details there. And then there's also a main method. Now the main method in Java is special. We've got a public static void main method. This is where the program starts executing. And so then I'm going to show you how the main method is used. I'm going to go into the student directory here. I'm going to let's see here. This has my pom.xml. This is where my project lives. I'm going to use the Maven tool to build the project. So I'm going to say Maven W. I'm going to use how about Maven W verify. Oops. What Maven W verify does is it runs the project through all of its phases. It'll compile the code. It'll compile the unit tests. It'll run the unit tests. If the unit tests pass, it'll run the integration tests. And then verify that the integration tests are all working. We'll talk about integration tests in a little bit. But this is the end-to-end life cycle. Oh, it'll also create any artifacts associated with that project. And in this case, we have an artifact which is called an executable jar file. So a jar file is a Java archive. It's basically like a tar file or a zip file with like all the things you need to run a Java program, like all the class files, and if there are any, well, I don't know, images or icons or sounds or anything, any text files that are needed to display string and stuff like that. It's all bundled together in a jar file. And the jar file built by this project is what's called an executable jar file, which means that it will run your main method if you say java-jar and then the name of the jar file, which is the target directory. All built components by Maven go in a target directory. And you've got student 1.0.0.jar. And when I run this command, this will invoke the Java virtual machine with that jar file. It'll run the main method, and it prints out the text missing command line arguments, which is exactly what the main method does right now. As a matter of fact, if I just change this to say, hello everyone, and I rerun my my Maven, this might fail actually. I think this might have a test might fail here, but that's okay. If I go and I change it. Oh, sure enough, one of my integration test fails. We'll look at that momentarily, but I believe it updated my jar. So now if I run it, it now says hello, everyone. Okay, so this is how you compile a Java, how you build a Java program with Maven. Maven takes care of all the details of how do I compile and where do I find the source code and where do I put the compiled.class files and how do I put everything together. It does all that for you. You just need to know these interaction points like running Maven Verify to do your complete life cycle and then running the executable jar file. But before I undo this change, move on, any questions about what I've shown you so far in terms of how to use Maven to run the program? Nope, okay. Cool. Yeah. Nice. This is the kind of thing you're going to be working with in your projects, right? You too, when you create your project one, you'll be running Maven Verify to run the code. You'll be writing unit tests. We'll see integration tests a little bit later. Okay. So I mentioned things like this toString method returns a string that describes the student. What is that all about? Oh yeah, and here are some of the steps that we just went through. So if you need to review them, they're all right here. Okay, this is, oh yeah, question, yeah. Correct. Git status only works with a local repository, local checkout, local clone. It isn't until you do a git pull that it will go and fetch the changes from the remote repository and try to integrate them in. Good question. So, the intended behavior of this program is the following. When you provide options on the command line, then it should print out something like the following. So so basically what you do is on the command line, you provide information about the student, like the student's name, the student's gender, the student's GPA, and then what classes the student is taking. So in this case, when you run the student program with Dave, male, 3.64, algorithms operating system Java, it should print out the following. Dave has a GPA of 3.64 and is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. And this all comes from so all this text right here is returned from invoking the toString method of the student object. So what you do in this program is when you create a student, you'll need to remember the name, the class's GPA, and everything like that, and then format the string that we expect in the toString method. Any sort of questions about like what that what the requirements are and how to interact with this code? We'll start implementing it here in a little while, but first I want us to explore the test scenarios for this code. Again, what you'll have is 2 things. You'll have the class itself, which has the student constructor and has the methods, and then you've got the command line interaction right here. So let's see here. So here's what I'd like to do. Very shortly, we'll break into groups of about 4 or 5 people, and so then I don't know, you can have a couple here in the room, and then I will create some breakout rooms online on Zoom, and we will do the following. You've all got a link off to the student PDF, so you can talk about and review some of the things we talked about. And what I'd like you to do is brainstorm and capture some of the usage scenarios using given, when, then. And so then there'll be some groups that focus on just the student class. Basically, this table right here saying, hey, listen, when I create when I create a student given with these values in the constructor, when I perform some operation, like I call the says method or I call the toString method on it, then the result is whatever it should be. So, like for instance, I've encoded the requirement that all students say this class is too much work as the following. When I create a student with any valid value of name, classes, GPA, and gender, when I invoke the says method on that student instance, then the result of that method is this class is too much work. Similarly, for that example that we had at the bottom of the assignment right here, When I create a student object with a name of Dave, with those classes, with that GPA and that gender, when I invoke the toString, then the result of the toString method is that whole string I said before about David's GPA of 3.64. And what I'm going to ask you to do is brainstorm what are some other scenarios, right? So given other inputs, what should the outputs be when a given method is invoked? So people in odd number breakout rooms, or we'll divide it up here in class, will focus on the test scenarios for the student class. People that are in even number breakout rooms or side here in class will focus instead on the behavior of the main method. So like when you invoke the main method, or or invoke the program with things on the command line, such as Dave Mail 3.64, that example that was there in the project, then we capture what was rendered to standard output and what was rendered to standard error. Right, because there's a difference between the behavior of the class itself, the Java code, and the behavior of the program. There are different inputs and different outputs. And I think it's valuable to be able to explore each, although I'm sure some of the scenarios will be very similar, but some of them might be very different. So, before we break out into groups for 20 minutes or so, any questions about what we'll be doing? Okay, I'll create the breakout rooms first, and meanwhile, here in the classroom, let's see how many people we have. We have 12. So let's do 3 breakout rooms. Yeah, let's do 3 breakout rooms. I'll let everybody choose which breakout room. Please try to distribute yourselves evenly. Have, I don't know, like 3 or 4 people in a breakout room. And then folks here in the class, yeah, find someone who's sitting next to you, break out into a group of 3 or 4. And then figure out amongst yourselves whether or not you are focusing on the constructor or focusing in on the command line. We'll be back in 20 minutes. Okay, let's get back to it. So I'd like some feedback. How was that activity? What did you find working in the groups? What were some of the things that like maybe helped, anything that hindered? Oh, right. It's like, okay, your team has an idea, and you're like, great, we should capture that, and someone already has. Okay, that's cool. Nature of collaboration. Great minds think alike. Feedback from the Zoom folks. It was kind of confusing at first. Can you say more about what might have been a little confusing about it? Did anybody else find it confusing? Okay, great. What did you, what? Well, no, I talk really fast. What about it was confusing, and what helped you get over that confusion? Right. Oh, good point. Okay, yeah. So right, yeah, we had a conversation here in class saying that, like, okay, are there other methods on the student class? Should we be adding other things? And the answer is no. And we just stay within the constraints that are laid out there. But yeah. Oh yeah. Okay. And going through that could be a bit more simplified. It might be. Feel free to make a suggestion, or if there's something that you saw. Oh wow, look, something about the assignment or something about the the structure here. Or maybe yeah, starting off with something simpler than a student. But yeah, studying the argument list for the student constructor, really understanding the code. Great. For the people that worked on the command line, we got lots of good examples here. Any thoughts about the command line and how to write test scenarios for that? Cool. Okay. Good deal. So what we're going to do next is we're going to go through these test scenarios and implement them as unit tests, right? You saw Uncle Bob write a unit test. I hope you had an opportunity to review the JUnit lecture before we get here. We're using JUnit and Hamcrest to implement these as unit tests. But first, I think we need a little break after all that. So let's take 10 minutes, and we'll come back here at 7:15. Okay. We had a nice break. I figured give us all a palate cleanser before we dive into some coding here between now and the end of class. So, okay, we put together all these scenarios, and I think where I want to focus first are the scenarios for the constructor. I'll be writing sort of traditional unit tests for these. The test scenarios for the command line will be implemented as what are called integration tests. That will be we'll talk about that later. So let's just review some of these first. So test case 1 here is, for any valid value of the parameters to the constructor, when the student says invokes the says method, then we get the result that we expect. This class is too much work. Great, we already talked about the second one also. Here's some other ones. I'm just sort of skimming these, figure out where it makes sense to start writing the unit tests. We've got some things where it's like, okay, here's a good one with the name of 123, algorithms 2.2, gender of other. When you invoke the constructor, it throws an exception. Why do we think this one should throw an exception?
The name is a number and not a string.
Okay. Great. Okay, so name cannot be a number. Okay, yeah, that's cool. I think that constraint wasn't called out, but I think we can go with it. We'll see, and I'm sure someone the child of someone famous and eccentric will have a number name, and we'll figure it out. Yeah. Yeah. Right. Yeah. Oh, I like this one. We have an invalid GPA. Here we have. Okay, great. When classes is null, then it's 0 classes. That's cool. That's cool. Yep. Here is a gender which is not supported by the program. GPA is too high. Super cool. Okay, it looks like, let's see here. Here's one that tests gender of other. And with they. Very nice, very nice. Okay, this is good stuff. I want to start writing some code. Empty inputs, all this kind of stuff. Great, okay. I'm just going to start at the top. I think we'll just go down and see where it goes from there. So, I'm going to go over to IntelliJ now. And so what I'm going to do doing some test room development, kind of like Uncle Bob was doing. I like to have a split screen with my test on the right and my code under test on the left. So I'm going to open in the test, student test. By the way, there's also an IT directory that has the integration test. We'll talk about that later. So I'll open up student test, and I'll do the following. I'll right click up here, and I'll say split and move to the right. Nice, and I don't need this thing anymore. So over here on the right, I have my unit test, and over here I have my code under test. And look at this. It comes with a test out of the box here, which is called student name Pat is named Pat. So I I have a name variable here, and I create a student named Pat. I just use a var because we know it's a student. And give it the name, the constructor, a new array list, so there are no classes, a GPA of 0, and a gender of doesn't matter. And then I use this assert. Now, I hope you all watched the lecture about JUnit, and in that, you learned that there is this library that we like to use in this course called Hamcrest, which is all about matchers. And so it allows me to make rather fluent-looking assertion statements. We can say assert that pat.getName, so the value returned by getName on the pat object, is equal to the variable name. Right? I pass in the variable name to the student, and I expect that it's the name of the student is the value that I pass in. Okay. Now, IntelliJ, it knows about unit tests, and the way it knows that JUnit test is that it's annotated with that test. And you see how it has these little green play buttons, if you will, in the margin. This allows you to run the test. So if I click on that, I can say just run the test. And this will build the code in IntelliJ, and it'll run the unit test. And so it'll execute this code, and what we should see is that the test passes because the name method is already implemented. In fact, it's inherited by animal. Oh, good, it does. Okay, So now let's, I don't have one of those stupid looking red, green, blue hats, but let's do the red first. So going back to the test case, any valid value to the constructor, when you invoke the says method, it should say this class is too much work. Okay, that's cool. So I'll write a test, and the name of the test, let's see, all students say this class is too much work. Now, I prefer to have lengthy descriptive names to my test methods. It doesn't cost you anything, and it makes it super clear. And yeah, I got to type a little bit more, but you know that's the way it goes. Now let's see here. Any student. So I'm just going to like make my my Pat student again. I'm just going to copy this code down here. It's the quickest way for me to make a new student, and I will assert that Pat.says this class is too much work. Oops. I'm going to say equal to this class is too much work. The nice thing about Hamcrest, well, actually, as we'll see in a moment here when we run the test, is that the reason that I like Hamcrest is not only because it makes the assertion statement easier to read. The error messages when something fails are much more clear. Okay, so what happens? We ran this code, and an unsupported operation exception was thrown saying it's not implemented yet. And it prints out the stack trace. So this is the code that was executing when that exception was thrown. As you can see here, here's our student test. All students say this class is too much work. So it's running this method. And then on line 29 here, it says, oh yeah, it was invoking the says method. It even underlines it in red. And when you hover over it, it even tells you what the error was. That's super nice. And now when you click on student.java line 34, it takes it over there. And oh, sure enough, it throws an unsupported operation exception. Okay, so this is red, right? The test is failing. Okay, what can I do to make it green? Keep going. Yep. Implement says. Yep. Yeah. Okay, right. Yeah, do what the Java docs say, which is what? Return this. Oops, all capitals. This class is too much work. Okay, nice. I made that change. So now I'm going to run it again, thinking that'll be green. Let's see if it is green. Oh, what didn't it like? It says, expected this class is too much work, but was this class is too much work? What's going on there? Oh, there's a typo in the test. This class, is too much work. Sure, I did that on purpose because it allows you to see like the nice error message here. You can say click to see difference. And oh yeah, right. That makes it super obvious that I expected it, but was is. Okay. So now I just need to change the test. This is why you want to see the test fail first, right? Because it's like, oh, sure, it worked, it didn't. Well, there was a bug there. Okay, I'm going to run that again. And there's lots of ways to run tests. You can do it here from the class. You can do it here from the test running method. Oh, good, it passes. Sweet. Okay, so now that was my red. I moved to green. Opportunities for refactoring. Yeah, right. Like this doesn't. Yeah, there's some duplicate code here. So let's see here. Oh yeah, so how about we just do this? How about we just have a method that creates that Pat student? Why not? And so then, yeah, I could create a new one, but I'm going to use IntelliJ's refactoring tools. So I think what I can just do is, well, actually, you know what? I need that name. Well, I need the name up here when I assert it. So you know what I think I'm going to do? I'm going to create a method that just takes the name of a student and returns a student with that name. So I'm going to highlight this code right here. I'm going to go into the refactor menu, and I'm going to say extract method. This will create a new method, and I don't want to call it getPat. I want to call it getStudent named that. And so, right, it's creating a new method right here. Oh, and look, it detected that there was another place where that same code occurred. Yes, I want to replace it with that method call to. Great, and now you call getStudentNamed in both those locations. Any other opportunities for refactoring that you see? There's one more that stands out to me, but it's kind of subtle. We have this name variable right here in this method. we only use it in one place. Do we really need the variable? Not really. I don't think it really makes anything easier to read. So there's another refactoring that you can do to get rid of this variable. It's called inlining. So actually, I'm going to right-click on it here to show there's another way to do it. You say right-click, refactor, and say inline variable. And that replaces the usages of that variable with the value of that variable. Makes the code a little bit more compact, because here in this case, it doesn't really matter. Well, this is cool. And now I'm going to run, actually, I've changed all the code, so I should run all the tests again. This is something that I don't think Uncle Bob emphasized, but after you do your refactor, you should always run all of your tests just to make sure they still pass. And they do. You know, there's one other refactoring that I see that I want to do here. This get student name Pat. It doesn't have to be Pat. We don't care. So we can just call it, anything. And now the variable, we don't need to make that variable be named Pat. We can just call it, we'll call it student instead. So another refactoring that you can do, I love refactoring. Refactoring, you can say rename. You can rename that variable and just call it student. And it renames the usage of it. Run your test again just to make sure everything still passes, and it should. Remember, refactorings don't change the behavior of the code, it just changes the look of the code. Yay! Okay, and it is. Great. Okay, so now I wrote my first unit test here. I like to commit my code after things are working. I like having a stable point, and I know it. And so I am going to then commit the code to Git and then push it to GitHub. First unit test. I'm going to commit and push it. Oh, it gave me some warnings. Probably things that aren't implemented. I'm going to ignore them for now and push it up to GitHub. Sweet. Oh, question came in. What should I do if my JUnit in the import is not being resolved? Let's see here. Did you happen to run Maven package before you opened IntelliJ? It might not have the jar for it yet. So you might need to run Maven to download all the jars for JUnit. Give that a try. And if it still doesn't work, then after class we can stay for a couple of minutes and get you all fixes. Yeah, that's an important thing. You got to make sure that IntelliJ is happy with all the code that you're using. Thanks. Okay. So we got that one test case done. Yay! Let's just turn that one, give that a green background color to show that, yay, we did something. Well, let's have a nice back green. There we go. Okay. Oh, here's the next one. This is like the big end-to-end one. So yeah, let's take a look at this one. So we'll just call this so we're in our test, and we'll call it Dave student. So I'm going to have a student variable called Dave, which is all those things. So okay, the name is Dave. The classes, well, we'll create that shortly here. I'll also have a classes, yep, classes array list. Actually, I'll just go and create that now. So you can use Alt-Enter to basically fix some problem. It was red, so I'll go a little faster. So like it's red because it's complaining that it can't resolve simple classes. There's no variable, so you can create that variable by doing it's Alt-Enter. And say create local variable. Yep, I will do that. Yay, created that. What is it complaining about now? Oh, it might not have been initialized. That is true. So we'll create a new array list. By the way, array list is a collection. You'll learn about it in the collection classes lecture. You can probably figure out pretty much what it is then. Let's remember ourselves what classes we're taking. Algorithms, operating systems in Java. I'll just say that here. So. Oh, yeah. So you'll learn about in that lecture is that there's hierarchy of classes and interfaces. Array list implements the list interface, therefore an array list is a list. It's often nice, and you'll see it in your assignments, to use the more abstract interface types, because then you can change out the implementation of it. I think, yes, as a matter of fact, I think a good refactoring for this would be to use list instead of array list. But it's the first project, I wanted to be a little bit more concrete. So, yep. Algorithms, oops, classes.add, See how IntelliJ is prompting me for like, hey, did you mean this method? That's a nice thing about the IDEs. They know the language. They can guess what you're going to add. Operating systems and Java. Great. Okay. The GPA is the next one. Yeah, GPA is 3.64, and the gender is male. Okay. Cool. Okay, so in this case, I should assert that Dave.toString equal to, and then this whole thing right here. Okay, let's see here. Oh, I always put 2 spaces after my periods because apparently I'm a Gen Xer if you do that. Yeah, and this all looks good. You got commas in there and everything. So this is the test that I want. So let's run it. Now, does anybody expect us to pass? No, right? This is like the end-to-end test. This is ultimately what I want to get to. But I think it's good for me to implement it now to sort of see how close I am. And I can use this as a bellwether to see like how close I am to getting everything to work. And so right now it is throwing, oh yeah, look at that. It is throwing a not implemented method from the toString because, oh yeah, toString isn't implemented. Well, that's interesting. Okay, well, that's good to know. So, you know, when I look at this test, it's like, this is gonna be like the last test that I get to pass, right? I mean, once this thing passes, I've sort of implemented all the Hattie Bath anyway, functionality. So I'm glad that I wrote this test, but this isn't a test I'm gonna try to drive to green right away. This helps me just understand sort of like the point I'm gonna get to. So what I'm gonna do is I'm gonna mark this test, I'm gonna annotate it with @disabled, which tells Jane, it's like, this is a JNet test, but we're not gonna run it. So this way, you know, I don't comment it out, because if I commented it out and then I like change the name of methods or something like that, then it wouldn't compile when I uncomment it again. So I'll leave it as real code that's compiled, but I'll tell the JUnit framework, like, don't try to run this test. You know, this seeing that the toString isn't implemented yet gave me an idea. So we know, I guess we didn't really call it out here in a test case, and I think that's okay. I don't think we had a test that says that the toString always contains this class is too much work. So I'm going to write that test right now. I think that'll help me begin to implement the toString method. So avoid toString, well, I'm going to say student toString contains this class is too much work. Okay, so what I'm going to do, I'm going to create my student. I'm going to use the new student. What did I call it? Create student. What did I call that thing? Oh, get student named. Yeah, I like that. I don't actually. You know what? I don't like get so much anymore. I want to rename that to create student named. Right. This is refactoring. You know, I look at my code. I'm like, I think this would be a better name for it. I think it's more expressive. I'll just rename it. Easy peasy. And yeah, I suppose I could have waited if I really wanted to be strict about it. I could have waited to the blue part of the red-green refactor, but you know, it's all right. Let's call it student, and then I will assert that the student.toString. Now it's not going to be equal to this class is too much work, but it's going to contain. So contains string. I think that's what it is, and it doesn't recognize it, but I think I can import it from Hamcraft. That looks good. And I want it from Shore. That one. Okay. This class is too much work. I spelled it correctly that time. Cool. Okay. So here's another test. I'm going to run it. It failed because toString isn't implemented yet. Okay, that's okay. How should we implement toString then? What should we return here? To make this pass work. And all we want to do, we want to implement the minimal amount of code to make this test pass. Because I don't want to think about everything else yet. I just want to, like, what is the minimal amount of code to make this pass? Make it an F string. Say more? Oh, yes. Gotcha. Okay, format a string with the information. What what information should be formatted in this toString? And again, we're just doing enough to make the test pass. Yes. Right. So all the no, this is good. This is test-driven development, and actually, like you were saying at the beginning of the class, it's this urge to like, I know how to implement that. I know how to implement it. Take your time, right? Slow your roll. Is that what they say these days? Anyway, so a toString, all we need to do right now is return this class is too much work. So how do we have this string return this class is too much work? Just return that. Or we can have it invoke the says method, which is probably what the appropriate thing is, right? Because it always says that. And actually, there's probably more that we could write here. So not only this, but you know what? Well, I was going to say, says with double quotes around it. Actually, we should have the double quotes there. But the verb here will be he says, she says, or they say. So we can't. So we're not ready. We're not doing gender-specific pronouns and verbs yet. But what we can have it say is it should always be in double quotes. And yes, there should always be a space before it. Right. I mean, we can write this test now, and so then yeah, let's just do that. I'm going to start using some keyboard shortcuts. I believe the keyboard shortcut on a Mac, or at least my Mac, is what? Control Shift R to run this test. So I'm going to do that. This is going to fail again because I changed the test. Nice. Okay. And again, it's like I expected a string with like the space and the double quotes. So I'm just going to add that here. And then, is there a period at the end? I guess there is. Yeah, so let's, not sorry, the world's best most disciplined test-driven development, but that's okay. Let's try it one more time. Now, the thing about like what we demonstrate here in class is that, yeah, these are pretty simple problems. And when you do, like when we do the mobbing session, and we do like the FizzBuzz kata, it's super simple, and you're like, I know how to do that. Why would you do test-driven development? This is how this is me teaching you test-driven development. I don't want the problem domain to be too difficult. I want to be able to work in small steps. I'm working in small steps. You're probably like 7 steps ahead of me. That's fine. But I think you take the discipline to like sort of make the notes, like, oh yeah, I'll need to do that, put it all in the parking lot. You'll actually get there faster, in my experience, and trying to like bang it out all at once and then figure out, well, does it really work? How do I test it? Okay, I'm going to quick commit this because I'm going to run all of my tests since I haven't done that in a little bit. Let's see here. I can just run them all. Yep, run them all here. Nice. Okay, so let's see here. ToString contains the value that it says. Okay. Now let's go back to this. Let's see here. Oh, so I implemented this one. Implemented that one. Oh, nice. This is that name cannot be a number. Okay. Let's see here. How can we express this one? Any ideas on what should be in this test? So student equals create student named. Actually, what should this be exactly? Yeah, right. Well, let's write the test first, and we'll figure out how to implement it. So let's see here. What do we want to do here? When we create a student, and the name is this, we should get an exception. Name cannot be a number. Okay, I like that. What kind of exception should we throw here? Oh, okay. Yeah, illegal argument exception, I think is the name of it. Okay, sure. Yeah. Okay, actually, so let me change the name of it. It should be student with name that is a number, throws illegal argument exception. Now, as you probably experienced through the koans, Java has a mechanism for throwing exceptions and stuff. And as I hope you saw in the JUnit lecture, Hamcraft, or actually JUnit, has a nice API for validating that a method throws an exception when it's expected to. So it's called assert throws. I'm going to import that here from JUnit. And it takes, the arguments are a little interesting. It takes the expected type. This is where you use the class. So you say illegal argument exception dot class. And then you pass it what's called an executable. And you can use the Lambda syntax. Yeah. Sorry, yeah, I'll go back again. I did import it. What I did was, and actually, let's see here. Did it take out the import? I'm going to remove this. Oops, I'm going to remove that. So I typed it. I said assert throws, and then I put two parentheses. That way it knows it's a method. And so I hover over, and it's actually telling me, oh, hey, did you mean assert throws here? If so, you can use Option Enter or Alt Enter to then get up a little context menu that says, yes, import that method. So that's how I did that. Yep. Yeah. Thank you for asking, right? I go fast, but I always don't know what sticks in and what doesn't. So, and then we say legal argument exception. That's the type of exception that's going to be thrown. And now you have the code that's going to be thrown. And so this is a new executable. Executable, I don't know. Anyway, executable, yep. And so I can create a new executable here. IntelliJ will create an anonymous inner class for me, and its execute method is the code that you think will throw the exception. So I can actually just move create student named up here. So just cut it. Because I don't even expect it to return a value. And okay, and so I want to assert that this throws an illegal argument exception. So I'm going to run this code. Now, what do you expect would happen here? Right, the exception isn't thrown, and it fails. It says, oh, I was expecting that an illegal argument exception would be thrown, but nothing was thrown. Okay, fair enough. A couple other things I want to note here. So IntelliJ has got something gray, and it's telling me some things. So it's got this throwable in gray saying, exception job length throwable is never thrown in the method, and it's telling me I can correct it with remove throwable from an execute throws list. That's cool. I'll do that. Yeah, okay, right, that's code. But it's also telling me something up here. Anonymous new executable can be replaced with a lambda. Once you do that, replace it with a lambda. Okay. This was called a lambda expression in the Java programming language. If you've done any functional programming, you've probably seen things like this. There is a lecture about functional programming a little later on. But for the time being, just know that is a shorthand for calling the create a student name method. So I just made those code changes. I'm going to run it again, which will see exactly the same result. Yep, still nothing was thrown. A couple more things before we start implementing that I wanted to use to demonstrate the JUnit API. Assert throws. I hover over it, and so now I get a description of the method and what it does. So assert throws, you can see here, it returns something of type T, which is a throwable. Assert throws returns the exception that was thrown. This is good because we want to get that exception and make sure that its message, the message for the exception, is what we expect. So name cannot be a number. So I'm going to do that right here. And the way I'm going to do that, well, I'll say illegal argument exception, and I'll call that exception equals, well, the value returned by that class. And then down here, I'm going to use the hamcrest to assert that exception.getMessage is equal to, what did I say? Name cannot be a number. Name cannot be a number. Okay, now when I run this, of course it's going to fail because it doesn't even get to that assertion. It doesn't get to assert that statement because the assert throws Fails. So now I think I have the test the way I want it. It validates a couple of things. It validates that an exception is thrown and that the exception that is thrown has the message that I expect. Right? This is the behavior of the class that you want to see. So let's do that now. So how do we implement this? So let's see here. This ultimately, we want this code to be thrown by the constructor, right? Yep. Okay, so now we need to have the constructor throw an illegal argument exception if the name is a number. So, well, you know what? I'm feeling verbose tonight. Throw illegal argument exception if number. Well, assert throws just says it was throws. But I also want this assertion down here, which says the message is what I expect, because the illegal argument exception could have any message. It could be an illegal, no, very good question. It could be an illegal argument exception for a different reason. Like, oh, let's say it's illegal for names to, to be valid SQL syntax, right? Little Timmy drop tables, right? Right, yeah. So, right, so we want to be specific in our tests, right? And that way we make sure that, the code really behaves as what we expect. So it's great. I added this check in here. It says throw legal argument exception if number. And then what I can do with the magic of Alt-Enter is I can create that method. Okay, and there it is. It has the name. Let's call that string. Okay. So now, how do we determine whether or not this is we should throw out a legal argument exception here? Oh, yeah, we could iterate over the characters of the string, and if all of them are a number, then yep. Let's see, but we also need to account for negative numbers, right? And like, what is it, a decimal? I don't know, is it decimal? We're not really testing a decimal, so I don't know. What do you want to do? Okay. So, turns out there's an API that Java has for converting a string into, let's just say an integer. And that is an integer.parsint. So let's see here. And so we'll call integer.parsint on the string. Now let's get the logic right here. So if it is successful with parsing the string as an int, then we want to throw the illegal argument exception. So then throw, new illegal argument exception with the message name. Cannot be a number. Cannot be a number. Right, so I was able to parse it successfully, and I was complaining, oh, it's saying that the result of integer.parsint is ignored. Yeah, that's true. Let's see if that works now. Oh, it passed. Okay, right, because when I called the constructor, I passed in a number, it was able to parse it successfully, and then I threw the illegal argument exception. Great. Okay, well, I got that one to pass. I want to make sure all my other code passes. What do you think will happen? Red all over the place. It's saying number format exception for input string Pat. Oh yeah, this is that great student named Pat. Oh, right. I pass in the string Pat here. I call parsint, and when parsint fails, it throws a number format exception. So how do we fix this? Yeah. If parseInt throws the exception? Oh, right. So if parseInt throws it, it's cool, right? Okay. Do we know how do we express that in code? Right, I heard someone say try. Yeah. So we want to wrap this whole thing in a try catch block, and if it does throw a number format exception, this is good. So then everything's happy. What is it complaining about? Oh, it's probably an empty catch block. Name is not a valid number. That's good. Nice. Okay. Let's run it one more time to see if everything passes. Yay, everything passes. Okay. Red, green, any refactorings that you see? Yeah, any questions? Oh, the one that I always do, so you can use this one up here to run, if you run like the one in the margin next to the class declaration, or if you say run tests from outside of a test method. So I click here on this line, which is inside test method. Yeah. So like what I usually end up doing is just click here outside of a test method, and then I use the keyboard shortcut Control-Shift-R. Yeah. Okay. Well, cool. Excellent. Okay. Well, we got another test passing, and it's I'm going to commit this in, and then it is time to go. So let's see here. What did I do? Oh yeah. If the name is a number, throw an exception. So this is how I like to do test-driven development. I first come up with I brainstorm like what are the scenarios? What does my code need to do? I encourage you to do that as part of your project, which you'll learn about next week, so that you can sort of understand the boundaries of what you'll need to build. And then I implement those scenarios as test cases. And I use those scenarios to drive my implementation. And along the way, I get this feedback, right? I know that not only did the new test that I write still work, all the old tests that I wrote 5, 10 minutes ago, 2 hours ago, 3 days ago, still work also. There's a lot of power in this because I have confidence that everything's still working. We've all been there where you work on something and you introduce a bug and all of a sudden something that's been working for days isn't all working. Why, right? This is the problem with working in big batches. Test-driven development encourages you to work in baby steps, and actually, even though you're taking smaller steps, you get there faster in the end. Cool. Okay. That's everything for tonight. Thanks for staying. A couple of things for next time. I don't know when we're starting exactly, so if you don't hear from me otherwise, let's assume 6:40. Also, because I realized that MLK Day, we don't have class, I need to juggle things around a little bit, so I'll let you know how things change. And in the meantime, keep plugging away at those koans. Awesome. Have a great night, everybody. I'll see you on Wednesday. Thanks for joining people on Zoom. Bye.
Thank you.